Welcome to the Air Power Airwaves, the Air Power Manufacturing Solutions podcast series where we talk about manufacturing issues that impact you. Hey, it's Travis, and welcome to another episode of Air Power Airwaves. Tonight, we have Carlisle Fluid Technologies in the house with Mr. Allan Mustard. How you doing, Allan?
Hey, good to be here. Thank you for having me.
Thank you for dinner last night. We had a good time.
Enjoyed that very much.
So, yes, we do our homework for these podcasts. We actually just happened to eat while we did our homework last night. What's up, Len Morrison?
How are you, sir?
Doing good. So, both of you account managers. You're account manager with Carlisle Fluid Technologies.
Yes, sir.
You have quite a big reign of territory, don't you? Like multiple states?
4 states, okay. Georgia, South and North Carolina, and Virginia.
And you actually live in one of my favorite cities.
In the Cleveland, Ohio area?
Yes,
sir.
I go way back to Cleveland, Ohio, a long time ago. We'll probably talk about that at some point. And then Len, you kind of live in the land of my ancestors that I've just recently found out.
Western North Carolina.
Yes, Western North Carolina, and you've been with Air Power a number of years now.
5 years. 5
years, and you've been in the finishing industry though.
Probably close to 20.
20. Okay, so we're going to talk about a topic that is a big deal to Air Power. I know it's a big deal to Carlisle. But it's a very big deal to many of our customers. Wood industry or wood finishing trends in the industry. And this is a big deal to Air Power because anybody who knows Air Power knows where we started. We've talked about that in other podcasts. This company was built in the heart of the wood furnishing capital of the world, High Point, North Carolina, and in other cities around here like Lenoir, where we had a branch, Raleigh, Charlotte. This whole region up here has been massive in the wood finishing business. So it's it's a topic that's near and dear to our heart, and we still maintain strong relationships throughout the wood industry, and that's now expanded all the way to basically Pennsylvania, New York-ish, Maryland, all the way down to Florida, and the entire Southeast and all up the Eastern Seaboard. So with that said, I want to get started on this podcast. And let's talk about, there's a number of things that we have picked out as a group, the three of us, that are topics that we need to cover or highlights that we need to cover in this. One of those would be substrate. So when we're talking about wood industry trends, we kind of have to visit the old and the new at the same time to kind of see where and why it shifted. So does anybody want to start talking about that a little bit? I mean, I can throw some softballs here from what we talked about last night, but back in the day, it depends on what you're dealing with, but back in the day we were dealing with hardwood,
Well, it was like we were talking in at the turn of the century, pretty much. The industry moved from primary focus manufacturing in this part of the country to overseas, to a lot of overseas locations, and they used different species of woods as their supplier chain. So that changed what woods we focused on and how we structured the equipment and the chemistry to accomplish that. So that was a big challenge for us, as well as the lower cost imported hardwoods that did come here had to be finished here using the equipment that we used for the other hardwoods that were more domestic. So that changed the industry a lot. Then, even beyond that, engineered wood, so different composites, MDF, HDF, those grew in popularity as they learned how to make them more robust and durable as a construction material for furniture, for cabinetry, for the wood wood industry.
Yeah.
So that changed things a lot.
The old school fiber boards where you one screw in, and if that screw would barely hold it just yank out and put sawdust with
Sure.
it.
We found that plywood was really strong. It could twist and bear a lot of different directional pulls
Right.
in construction and in use that made it a great resource for us. And then they took and created a core that was the composite material and put veneers over that.
Yep.
So it changed a lot in the last 15, 20 years.
So you mentioned a couple terms, MDF and HDF. So we're talking medium density fiberboard and
High
high
density.
density fiberboard. What's the difference between those? I know the word. I know what MDF is. I've worked with MDF on the powder side,
Right.
and it has its own complex world. You got to control the humidity level in the board itself. So people are building environmental rooms just to keep the boards in for storage, to keep the humidity levels at a certain point.
Yep.
What is the high density?
Well, first, MDF is great for construction, but it's not as durable, it's not as dense, so it doesn't have some of the properties that you need for a painted surface to be a Class A finish,
Okay.
to be very easy to finish. MDF in the past and in the powder world requires quite a bit of fill to
Right.
get that surface nice and smooth, and when you machine it, chunks of the fiber will tear out.
Yep.
Versus the high density, when you machine it, it remains very smooth.
Okay.
So it doesn't require as much finishing or as much even sanding and smoothing prior to finish as a result of that.
So when you have these huge flat lines where they roll on this giant sheet, and it goes on, and the machine is set up to where it's got a pattern or whatever, where you might cut out a whole kitchen out of one of these sheets.
Absolutely.
That's gonna be probably is gonna be more of a high density. That when it's coming out of that line, it's probably a little bit better on the edges.
Typically, they use HDF now for a lot of those applications. It depends on whether a veneer or a film is being applied to it. So if that's not the case and they're coating it, high density, some composite, some density more than MDF is what they're using.
Gotcha.
The resins in it mean as much as the density of the fiber, how well they bond and how well they are resistant to chemicals and moisture.
Okay.
So the resin content is also a key component of that material.
And I guess this all drives something. When you're in production, you're seriously looking for repeatability.
Absolutely.
And I have notes here that we talked about this last night, that the term exact mass production. Anything that deviates on that is very easily rejected or has to be reworked. And in wood, sometimes the reject means you just bitch it and start over.
Completely wash
It's done. It's done. It's not like metal where you can blast it back and start over again. It might possibly be the end of life there. So
I would say in its infancy, MDF grew in popularity in our our industry because it was less expensive than plywood, less expensive than hardwood. But as the engineering of the product increased and improved, the material itself costs about the same as some species of hardwoods now, because it's that superior and that repeatable, that predictable, that it really does earn its keep. Now it's not a less expensive substrate necessarily, it's a better one.
Yep.
In some cases, especially since we paint a lot of our product now.
Yeah.
Which we'll talk about later, but
So, I mean, I know this isn't in the finishing side, but how big is the, So my wife and I have a house, and when we got married, I moved in, and the kitchen was a wreck. It had the old white. It was MDF board cabinets basically that had the MDF, and it was wrapped with some kind of a wrap,
Thermoform.
and it was just half of the doors that was just flapping on the door.
So the adhesive.
And I literally ripped out the entire kitchen, and I built a brand new kitchen, cabinets and all. I repurposed some cabinets from a house that was the exact house that we have, the exact floor plan, and it was solid wood. So I come from a wood background. That was easy for me. It was a lot of hard work, but it was easy process. But is that world getting better? Are those wraps you mentioned? I heard you say something.
Yeah, thermofoil wraps.
Thermofoil wraps.
The adhesives are getting better.
Okay.
Yes.
The adhesives are better, but there remains on the back edge of the wrap a joint that water and moisture and anything can get
Work
in
into.
and start to lift. So there are other ways to do it, like powder coat. There's no seam.
Yeah,
There's
and you're
no
able
joint.
to
It's
envelop
completely
the whole part. It was fascinating watching and listening and watching and actually performing it, doing powder coating on MDF board with like cabinet doors. People don't think about wood as being groundable substrate, having a ground situation, but that's one of the key factors for the amount of moisture, that the moisture content inside the wood, that allows you to get that wrap on the sides of the door and be able to get your film build where you need the electrostatics in the process. And it's just fascinating how that industry has come along.
So with the MDF, is it like the wood where you need a 7 to 11% moisture content?
Correct.
And if you don't have that, you could always pre-treat with.
You can.
I've watched shops where they take sponges with water and they sponge down the panel or the door.
Ground it.
But there's a special meter that's got little pins in the bottom of it, and they stab it into the wood, and they're checking the content of the moisture.
Content.
And if it's not up to par, they have to get the sponges, wet the whole thing down evenly across the whole piece, and let it set for a while. They'll even go set it to the side and let the moisture kind of soak in.
I would challenge you that the technology has improved.
Good.
Since your last
Yeah, it's been a while.
mopping exercise.
It has been a while.
The ability of the equipment that's available with infrared, for instance, you can preheat the substrate, which increases the energy level on the surface, which makes it more attractive actually to an electrostatic charge. Electrostatic particles are attracted to them easier.
Okay.
But also the heat raises the moisture content to the surface, making the surface more conductive as
All right.
well. So with a preheat, we're able to energize it without pre-treatments in a lot of cases now and have the success we need with electrostatics.
And that heat also, it's pushing that moisture out, and it's really critical on the edges of a cabinet door.
Huge.
You think about the amount of wear and tear that the edge of a counter, the door gets or the lips of a drawer versus the actual drawer itself. So, okay.
That's MDF. That's HDF. That's what's changed there. Veneers continue to be very, very popular. So, as a substrate, dynamic, that has also become very important because there's not as much hardwood to harvest and use in our industry.
Correct.
A lot more of our products have veneers on them when we're still using real wood.
And a lot of the wood that reproduces itself very quickly, for use in rebuilding forests or whatever, grows fast. It's not necessarily what we want to be building the furniture with.
Doesn't have the grain character.
The
doesn't have
density.
the colorant to it that you want in a wood that you're going to look at. You're
Yep.
going to finish.
All right, let's parlay that into the coatings. We've already started talking about powder coating somewhat, but let's talk about coatings technology. Uh, Len, you want to take us in some of the technology that's changed, trends that we're dealing with right now in like paint mixing, paint metering?
Yeah, so in an effort to be compliant with federal regulations, the lowering of the amount of VOCs that are emitted was the trend
Right.
in probably the late 90s. In an effort to do that, a lot of coating manufacturers tried to duplicate the solvent-based process with water-based process. And then when you got into the clear coats, two-component applications where the clears are more durable as a two-component system. So those were some ways that coating companies had to move in order to accommodate the reduction in VOCs.
Okay. And I'm sure anybody watching this podcast is going to understand what a VOC, volatile organic compound.
Yes, sorry.
No, it's fine. It's just it's the stuff that you don't want to breathe. It's the stuff that we watch. We don't want it released into the atmosphere. It's negative for our environment. So, it's good that EPA and other groups are watching things like this, because we certainly don't want to be the way things were back in like the glory of the Chrome days, where it was like, you live in the mecca of where that was going on.
Well, we have a beer named Burning River.
Yeah.
It's called Burning River for a reason.
For a
it's
reason.
Environmental in its roots. I would say that the environmental concerns have driven a lot of this chemistry change that we've seen. A lot of it was already in place in Europe, and we've
Yes.
been able to travel over there and study how they do what they do to meet those stringent requirements, and learned from them. They didn't do it perfectly, nobody does, but we learned from them and brought that back to our states and figured out what worked best for us. Like Lenny said, though, we converted in a lot of cases from solvent to water and tried to make the water work in a solvent line, if you will. The equipment was designed to support solvent-borne coatings and the way they operate. So that was a challenge for us because they're not the same. They do flash off and cure differently.
Correct.
So we needed to redesign a lot of our equipment to meet those needs and optimize the process.
So what are the different levels of equipment that we have? What are the different types?
So in low pressure spray applications, you have what's called air spray, which has been around since the beginning. It goes from air spray then to HVLP, which is high volume, low pressure. High volume of air, low fluid pressure. Then LVMP.
Low
that right?
volume, medium
Yep.
pressure.
Correct. And then you get into your medium pressure applications, which is air assist airless and airless applications. The low pressure applications were primarily used in the probably first in wood, stains, sometimes sealers. Then you get into the heavier materials, the 2K materials that are then sprayed with air assist airless or airless.
Okay. Now let's talk about the different proportion systems. The different ones that are out there. And I have on my list 2K, 3K. What are the things that are available today for our customer base?
So we have 2K mixing systems, Carlisle. You want to explain a little bit about what
Sure.
offering you have?
Sure, we have an entry-level system that mixes on demand. It measures the amount of the paint, the coating that you're spraying, and aligns the system to mix hardener or catalyst with it at a ratio from 1:1 to 100:1, just depending on the chemistry itself. So that's where we start, and then we add color change capability and efficiencies in the way that it flushes and rinses the components to make sure those systems are reusable and real versatile. And then we, for some more controlled technical applications, we need to manage the rate of flow of material to the gun, to the applicator, to make sure it's exactly the right amount of film. So that's a challenge that we have equipment to solve and resolve and manage moving forward. Efficiencies are critical. With this new coating technology, as we're about to speak to, the cost of those coatings goes up, and 2K equipment helps you manage that cost more
Right.
precisely, not generate the waste, really save on how much material you make per job. That's really important. This stuff's not free.
There was a couple other notes that we made when we were talking about this with different things affecting coatings technology, and one of those was pretty interesting: an LED UV cure.
Yeah, that's a real strong trend right now. I would say most of it evolved through the packing industry. So boxes and cans and glass got labels on them that was cured as quickly as possible because they're making millions a day. So that's very fast cure technology, and to manage that, they designed LED UV cure. They could more fine tune the wavelength of light energy used to cure those, and use less energy as a result of the LED technology, so it doesn't heat the product up. Some of that packaging is very thin and very heat sensitive, so this wouldn't heat it up.
Yep.
Now we've borrowed from that technology, and we can use that in the wood industry to coat the wood substrates and not have them heat up too much. If you heat above 150 Fahrenheit, wood splits
Yep.
every time.
You're talking low
So-
temp cures for sure.
Yep, so we need low temp cure, and LED UV requires a very low energy source, but applies it only to the film.
Right.
Only to the film. The substrate is not heated up as a result.
Gotcha.
Great technology, growing very fast. Very fast.
So, raw materials. COVID was a challenge
Yes.
COVID's effect has changed a lot of things in manufacturing. But as we talked about, one of the biggest things was the availability or the lack of availability of raw materials that we regularly saw. And I'm sure we're talking, this goes, it's such a wide spectrum. You could, from the shelves of Air Power, when you're talking about certain pieces and for replacement parts for guns or replacement parts for pumps, it could be just like one particular piece, like an O-ring. It's like,
Yep.
where is it? We can't find them anywhere, and then you got backlogs, massive installs held up by little things,
Fittings, yeah.
fittings for whatever. But in the coatings industry, there have been a lot of challenges even within like powder coating, for instance, the raw materials to get that were commonplace and used all the time. That all of a sudden now it's forcing a coatings company to reevaluate and re-engineer certain coatings with a different set of raw materials.
It definitely has. Like many other industries, some of the raw materials used only come from a handful of locations globally. The cost to manufacture them is so high that they only have a few facilities built. No one will invest in several of them to supply that. When COVID and the pandemic rearranged our whole logistic model for all of us in some way or fashion. It did that to the coating industry, and they couldn't even get those raw materials anymore. They weren't making them. The plant was shut down.
Right.
So a lot changed, and they had to resource other ways, other parts to the coating resin system or cure system to make it work anymore. So
Yeah.
that changed things a lot, and it's still affecting us as we continue to evolve through the new models that we have in our economies, our global economies.
And you know, another thing that's done is something else that I think Len brought up last night was when you're looking at challenges from the coding standpoint, you're also looking at challenges from the application standpoint. How does one affect the other? And we mentioned this earlier about repeatability, and exact repeatability is profitability. And there's I'm trying to get to a point here, but there's so many different things I'm pulling from. There is a point where the finisher is looking for the most economical way to get a good finish. What's they're looking at the price point of the product that they're buying to spray, right? The paint.
Sure.
They always look at the price point, and they you hear about these big contracts that get lost on like pennies a gallon or pennies a pound when you're talking about powder, and monster amounts of usage. But one other way that coatings has been affected is that the engineering that has gone into some of those coatings has increased, sometimes substantially, the amount that actual coating costs.
Very
But
much so.
But the payoff is in a dramatic reduction of rejects and repeatability and profitability one time through the system.
Yeah, it newly defined the equipment or the application equipment that had to be used in order to apply that to the substrate. So these this new chemistry, these new coatings defined what the manufacturers had to use in an effort to apply it. So technologies most of the time had to change. You had to go to a two-component system in order to apply the clears or some of the top coats. You had to go to a much more transfer efficient means of application equipment in an effort to reduce the amount of overspray because of the cost of the coating. You wanted to be as efficient as possible. So not only was there the need for them to step up and pay a premium price for the coatings that they're now being supplied, but the process in which they apply those coatings had to be upgraded in most cases. Yes.
Yep.
Yeah, the application window for more evolved engineered coatings, the application window narrows, but your controls as a result of that equipment Lenny's talking about has helped us manage that more precisely and make it more repeatable. We had to do the work. So the equipment was available. We just weren't using it in a lot of cases in the wood industry, and now we have adopted it. I consider myself a change agent. I like changing stuff a lot. So being able to finally help the wood industry evolve has been a real gift to me, and I've appreciated that very much. I've been in as many places as I could get to understand how to improve our industry and taking it to that point in manufacturing wherever possible.
Yep. Growing up in the wood business, my dad being a cabinet builder, when I was a child, I grew up an indentured servant in a cabinet shop. But I can tell you that that's followed me after years after graduating high school, moving off to college, and never working in the cabinet business again. But then selling equipment and selling things to companies that might be doing powder coating, but they also have a wood shop that they're doing cabinets or whatever.
Yeah.
My exposure then ramped in, and of course with Air Power, it just came back full circle. But change is not easy in any finishing environment.
No,
There has to be a lot of push and a lot of acceptance of change, because it's just not easy.
correct. There were some high-end furniture applications where you may have had 17 to 20 steps in the process. 17 different steps in the process. It could be anything from a sap stain to an equalizer stain to a fly speck or to simple distressing. But it was a step in the process. So trying to wrap your arms around these new coatings that are very expensive and can be done in fewer steps. Well, how do you apply that to something that historically for 100, 150 years had been done one way, and now in the span of about 4 or 5 years had to accept the fact that this is the way we are moving forward, and then completely redefine how your process is moving forward.
Yep.
It was a daunting task,
Yep.
at the least.
It was, and no offense to all of the customers out there, but the customer base, the market that we supply as manufacturers in the wood industry has become more insistent upon consistency. What I bought 3 years ago, I'm going to go buy another one, and it better match that one. Repeatability, the product has to all look the same and stay that way. So we didn't have that in the past. In the furniture industry, each piece had some uniqueness, had some character that made it unique. And we don't have that so much now. They all look the same, and there's craftsmanship there. Huge levels of craftsmanship to achieve those finishes at that level of repeatability and predictability is an art.
Yep. It truly is.
An art. It's a different art. It's a scientific approach that to me remains elegant, but at the same time, each piece is not as unique as it was because those 24 color steps aren't there anymore.
Right.
There are 4 in the place of 24. It's been simplified down, condensed down, and you still get an amazing product that the market rewards us with.
Yep. Agreed. And you look at just the steps, the old school steps in lacquer. It was like, put some of that poison deft on there, and then let it dry, sand it down, go another coat. I remember my dad doing like 6, 7, 8 layers of
Yes.
deft.
I sprayed asphalt.
Pure toxic, clear deft, and that's one of those reasons why I'm glad we have some of those laws we do now, because you know what? There's so many people that were living in some really nasty environments that had no idea,
That's right.
what they were living in. So, all right, so a little change of plans here, guys. This is going to be part 1. All right, part 1 of this podcast.
Okay.
And so what I'm going to do is close this one out and just tell you that if you have any questions, 1-800-334-1001. And if you want to visit us online, airpower-usa.com. If you want to buy something, go to shop.airpower-usa.com. And you can see us on all social media channels. You can find us there. Just look up Air Power Manufacturing Solutions. And then I'm going to close this one out by saying, manufacture it a great day.
Thank you for joining the Air Power Airwaves podcast. Air Power Airwaves is a production of Air Power Inc. and Air Power Live Studios and is hosted by Travis Steyerwalt. For more information, please visit airpowerairwaves.com. For more information on all of our products, brands, and manufacturing solutions, please visit airpower-usa.com. If you have any questions or need product support, please contact Air Power at 1-800-334-1001.